Welcome to Lecto. Today we are going to discuss ECG. ECG is basically a technique through which we can calculate the electrical activity of the heart and we plot it in the form of graph. Let's see. Actually, this is the structure of the heart. If someone calculate the electrical activity or measure the electrical activity of the heart, then one will put two electrodes, one at the apex of the heart. Here is the apex, and one electrode will be at the base of the heart. Keep in mind, it doesn't mean that someone cut the body and expose the heart and put the electrode over there. Not. Actually, when the electrical activity occurs in the heart, these electrical activity or signal pass or go to the skin, and we put the electrode over the skin and measure the electrical activity of the heart. Here is the SA node and here is the AB node, two nodes of the heart. We discuss ECG in three basic situations: in vector form, in what's happening in the cell, and in the graphical form. Let's see. Actually, when the heart is at rest, all the cells of the heart are in polarized state. What does it mean? Actually, when someone says that the cells are in polarized state, it means that inside of the cell are negative and outside of the cell will be positive. This is in polarized state, and the meter read it as 0 volt, because this is the negative electron, this is the positive electron, and inside will be charge will be same, so there is no potential difference and the voltage will be 0. Next, SA node sends signal to the atria. Here you can see SA node send signal to the atria, and you can plot a vector in this direction. Here you can see at what direction? From negative to the positive direction. From, if I write it here, from negative to the positive direction a vector will be plotted. It means the cells which are in polarized state will start depolarizing. Here you can see half of the cell become depolarizing and half are still in polarized state, and the deflection will be in positive direction. And if we see what will happen on the graph, here you can see this is the graph. Y-axis there is a voltage which are in millivolts, and x-axis there is a time which are in second. Here you can see I plot two ECG or two beats, cardiac beats. Actually, one cardiac beat having time 0.8 and other having also 0.8, and center will be 0 voltage and upward plus 0.5 plus 1 millivolt, negative 0.5 negative 1 millivolts. When the cells start depolarizing, half of the cell become depolarized. Then we see a peak, positive peak, and we see a positive peak, right? So this is the situation at which the half of the atria become depolarized, and this situation occur continuously, and a state will happen, and this state will happen that at a time all these atria, all these cells of the atria become depolarized, and when they becoming depolarizing, and again a decreasing curve will form, decreasing curve will form, and a time reach when all the atria become depolarized, and at that situation the voltage will be zero. The voltage will be zero. Here you can see at this is the ending of the depolarization at which the voltage will be zero. Here you can also see from here. So this is up till the movement of the atria or the depolarization of the atria. After that, the signal will move to the AV node, and at the AV node there is a stay. It means there is a stay, and the atria AV node remains in depolarized state for a short duration, and that duration will be, here you can see this is a small duration, voltage at which the voltage will become zero, and this is the 0.16 second, and the peak is actually the PP. The peak will form P. Next, the signal from the AV node transmit to the septum. It cannot pass to the valve because they are fibrous in nature, and the signal cannot pass through them. So the signal will attain a path through bundle of His having two branch, right branch and left branch. Right? Up till only the atria become depolarized. Ventricle are still in polarized state. Now the signal will travel to the through the bundle of His. Here you can see. But the signal travel in both the left and right branch. But the septum activate only by the left branch. Why? Because left branch has an other branch which is called septal fascicle, which transmit the potential to the septum. And what will be the direction of this action? Potential will be from positive to negative. Positive to negative. Here you can see the direction will be from positive to negative. Right? And here you can see that ventricle are in actually in polarized state, and they now start becoming depolarizing. And what will be direction from positive to negative? It means the needle will move towards the negative, and here the half of the cell now start becoming depolarized. Half become depolarized, and still half are in polarized state. Half become depolarized and half become still in polarized state. What will happen on the graph? Negative deflection, it means the graph will move in negative. Here you can see graph will move in negative direction. and this process proceed continuously. And it means when they complete the process, when all the septum cells of the septums become depolarized, then the voltage will again become zero. Why? Because the star cell becoming depolarizing and a state occur when there is no potential difference between the cell, and the voltage again will become zero. Here you can see the curve will again move toward the zero voltage, and the waveform here is called Q wave. Next we will see what happens. The potential this move in this direction from positive to negative. Next here you can see these ventricle cells become depolarized. How? Actually, if we draw a vector, the direction will be from negative to positive. Here you can see, you can draw a vector from negative to positive. Actually, these cells are also at first are in polarized state. But when the action potential reach and they start becoming depolarizing in what direction? From negative to the positive. From negative to positive, they start depolarizing. It means again concept zero. Half of these cells become depolarized. Here you can see depolarized, and half are still in polarized state. What will be the direction of the needle? The needle will start move towards the positive direction. So what will happen on the graph? Here you can see a sharp peak occurred. A sharp peak form. Only half peak will, if half become depolarized, and when they continuously depolarizing from negative to the positive, a state reach when the potential again move towards the zero potential. Here you can see that they becoming depolarizing. And at that situation, all the voltage will be zero. Here you can see this. Again, move towards the zero voltage. And after that, when this portion, apex portion of the ventricle become depolarized. And what about the upper part of the ventricle? Yes, the upper part will also become depolarized. In what direction? From positive to negative. In what direction? From positive to the negative. I write it here, from positive to the negative. Actually, at rest, they are in polarized state. And when the potential reach there, they start depolarizing. In what direction? From positive to the negative. It means they start depolarizing, become positive to the negative. Then what will be the direction of the needle? The needle will move in the negative direction. Only keep remember, half become depolarized and half are still in polarized state. Then what will happen on the graph? Here you can see negative deflection. Then you can easily the negative deflection in half downward. Only half, because half cells of the ventricle are now depolarized. And next, when this process, depolarizing process, continues from positive to the negative, then what will happen? A state reach when the all the cells of the ventricle become depolarized, become depolarized, right? And when the all the cells become depolarized, they will again move towards the zero potential. Zero potential. Why? The needle will move again zero. And this is the situation at which all the cells of the ventricles are in depolarized state. Here you can see this is the depolarized state. Now the ventricles now have to attain repolarized, a polarized state. Then what will happen? And keep remember, this depolarizing state of the ventricle remain constant for some duration. Here you can see this will remain for a short duration. Up till now we have discussed the first peak will form P, second Q, this upper is the R and this downward is the S peak. P, Q, R, S. And when all the ventricle are depolarized, then they will remain for a short duration. They will keep depolarized. Then now ventricle have to polarized. Then what will happen? Now the ventricle become depolarized in opposite direction. They depolarized in from positive to negative, and now they again repolarized or attain the polarized state from negative to the positive. It means they attain negative to the positive. And here you can see the cell was in depolarized state, and half of the cell become now polarized. What will be the direction of the needle? The direction of the needle will be in positive. And you can see on the graph that a half positive peak will form. Next, this repolarization process occur until a state reach when the potential again become zero. Why? Because when all the cell become repolarized or attain the polarized state, then the again potential will become zero, because at positive or negative electrode all the charge will be same, so the voltage will be zero. And here this peak also attain the zero voltage. And so this is the formation of the T wave. Next, this repolarized state remains end of the cardiac cycle. So do you notice that at the starting point, do you notice when we at the starting point the cells are in polarized state, and at the ending point the cell again become polarized or attain the polarized state. Next, you see that this then again after this 0.8 second, and again there is other cardiac cycle start and formation of peak, which is due to the depolarization of the atria, and there is a break which is 0.1 second, and after that QRS complex, QRS P wave, then Q, then formation of QRS complex, and after that there is an again break, and after that formation of the T wave, which is the repolarization of the ventricle. So keep remember that the repolarization of the ventricle can appear on the ECG, but repolarization of the atria do not appear on the ECG, because when the depolarization of the atria after the P wave, again a strong potential which is QRS complex form, which marks the effect of the repolarization of the atria. So if we compare the ECG with the diastole and systole, at the starting when there is a formation of the P wave, then at that situation which is 0.1 second, both the atria and the ventricle are in diastole state, and when they move downward, which is about 0.1 second, at that situation atria are in systolic state and ventricle are in diastolic state. Next, which is the formation of the QRS complex, at which the atria are in diastolic state and ventricle are in systolic state up to the T wave. Next, after that there is a zero voltage at which both the atria and ventricle are in diastolic phase. We have discussed cardiac cycle in previous videos. Here you can see this is 0.1 and this is 0.3, at which both the atria and the ventricle are in diastolic state. The total will be 0.4 the second. And here you can see atria remain in systolic state for 0.1 second, and here you can see ventricle at which the ventricle remain systolic state for 0.3 second. Now if we calculate heartbeat from the ECG, you can see that in 0.8 second one heartbeat occur. Then if 60 second, which is 1 minute, how many beats will occur? We suppose x. Now we find it. Cross multiply x multiply 0.8 is equal to 1 multiply 60. 0.8 multiply here, then it divide here. The answer will be approximately 75 beats per minute. So now we can calculate the beats from the ECG. So this is all about the ECG. If you have any question, then you may ask in the comment section.